Hello, am I audible?
Yes, sir.
Okay. So, can you guys see my screen? Is my screen is visible to you all?
Yes, sir.
Okay, fine. Okay. So, so now I think we are good to start. It's already 7:05. So, uh, so let's begin with our week 7 session of doubt and problem solving of techniques of material characterization. And this week we have entered in week 7, and here we will be try to solve some problem which will be helpful to solve your assignments of week 7. So if you have seen or if you have gone through the lectures properly, then you might be aware that of what is exactly going in this module. So basically in this module we had covered the signals and signals generated from the SEM that we have also covered in our last module. But here mainly we were focusing on our detector. How I mean, there are different kind of signals are generating when the electron beam is interacting with the surface of your sample. So depending on the signals that what are the different kind of detector and how can we distinguish amongst those detector to get a different signal so that we can get a good signal, or you can say a good imaging, or whatever we want, suppose elemental analysis or the topological or the some other information what we want. So it all depends on the detector. So if if the signal will accept by the detector, then only we can further process our results. Okay, so detector is one of the very important. So in this week we will be covering mainly on questions regarding our detectors. Okay, fine. So the first question is, why different detectors are attached in SEM? Okay, so why different detectors are attached in SCM? So as I have said that there are different detectors and every detectors has their own purpose. So they are asking about why we are using these different detectors in our SCM. So to increase the efficiency of the signal, efficiency means it is helping to improve the efficiency of the signals generated from our sample. To decrease the efficiency, and the detector is mostly specific for different imaging modes and analytical signals. There is no particular use and are attached to increase the cost of the microscope. So it is very obvious. If we will read the options, then it is very clearly. So please answer this question if you know, and it is quite simple. Can you guys tell me the answer?
It's a C.
Okay, it's a C. The
It's
detector.
C.
Hello. Yeah. So it's the answer is C, which is right. The detector is mostly specific for different imaging modes. Okay, so there are different imaging modes like your secondary electron and the backscattered electron. So every detectors has their own purpose, and we can use for that. So since in this detectors, so when our electron beam interact mainly with our specimen, so there is multiple event or the multiple signals got generated from the different depth of your specimen. Okay, so this so in order to detect that signals, because these are at a certain angle, and means every signals are having their own specification. So in order to capture those all signals, suppose secondary electron, backscattered electron, characteristics, X-ray, so we need to have a detector so that we can get these all signals. So here we can see in this, this is your sample, and here this is your secondary electron detector, this is your X-ray detector, this is your backscattered detector. So in this way we can say that the detectors is mostly specific for different imaging modes and the analytical signals. Fine, so the answer is C. Okay, so what is the primary function of acid detector? As I have shown you in this image, there you can see the secondary electron detector. So what is the main purpose of that detector? So to attract the low energy SE generated from the topmost layer, to attract the high energy SE generated, to attract the low energy SE generated from the bottom layer, or to attract the high energy from the bottom layer. So it is also, if you know about the characteristics of your secondary electron, that what is its energy level, and from which part of your surface it is generated, then you will be able to answer this question. So last week I have also explained regarding this. So can anybody guess the answer for this or give the logic?
I think it's A.
A. Okay. A. So it is absolutely right. So I will also give the clarification those who are not able to get it. So what it is saying, to attract the low energy secondary electron generated, since secondary electron from the name itself it is clear that it has a low energy, okay, because it is coming in the definition of the secondary electron in the last lecture also I have explained that it should have the energy less than the 50 electron volt, okay. So here it is also mentioning the energy of the secondary electron is 10 to 50 electron volt, is too low to excite the scintillator. So here it is saying about the energy. So it is clear that out of these answers, the SE detector, because SE is having a low energy, so obviously it will detect the secondary electron which has the low energy. But it is also asking about the from the top or the bottom. So since if you have remembered my one of the slides where I have explained you about interaction volume thing. So in the interaction volume, the depth from which the secondary electron is generated, which is not from the so deep, but it is almost near to the surface, okay. So to attract the low energy SE generated from the topmost layer of the SCM. So here this will be, so if we will be seeing this lecture, you will be able to get that how actually this detector is working, okay. So here there is something called the scintillator. So here how the electron is get generated, and when the voltage is applied, then this how it will get accelerated, and it will detect the secondary electron, okay. So it is also one of the very important thing that what is the name called for this detector. So here it is mentioning secondary electrons are detected by scintillator photomultiplier system. So this is very important. It can also ask in your exam what is the name of the secondary electron detector. So usually it is called ET, Everhard Thornley. Okay, Everhard Thornley detector is mainly responsible to detect the secondary electron. So please remember this name, guys. It is very useful and can be asked in any exams. So the answer is A. Okay, so it is again about the same detector, which is ET, which I have just mentioned the name, Everhard Thornley. So the ET detector captures only secondary electrons, only backscattered electrons, both secondary and backscattered electrons, and none of this. So one is very clear that I have just mentioned about the secondary electron detector. So, but if you think or if you have gone through the lecture, then you can also give your answer for this question.
C.
C. Okay, fine. So, is anybody other also wanted to give their opinion or answer, or just keep quiet and seeing the lecture that what we are discussing like that, or they don't want to participate or no answers? Okay, fine. So somebody has said the secondary and the BSc. So let's see. So secondary is for sure. Now we will come to the backscattered. So what is the characteristics of backscattered? Okay. So backscattered, it is, when the primary electron beam will interact with your samples, then near almost at 180 degree, uh, it will generated from the your primary electron beam. Okay. So BSc, so there is ET detector. So there all the, I mean, most of the SC secondary electron will detect by that detector, but there will be also some amount of your BSc signals. So BSc will also hit the scintillator of your ET detector, and that can be detected, okay. So it's not only like that, that only the your secondary electron will be detected by your ET detector, but your BSc can also be detected, even though most of the BSc will go in the direction of your near to the 180 degree, but there would be still some of the BSc signals can be detected by your ET detector. It is not purely, it is not purely meant for only the SC detector. So BSc can also be detected, and the signal is ET detector is not purely due to the secondary electron, as it does contain a small backscattered component. Okay, so if the scintillator bias is switched off or the collector is given a small negative voltage, then SC are excluded. Okay, so let me explain it in a bit. Just a second. Okay, so what it is saying is if the scintillator bias is switched off, okay, so when we will in scintillator, we need to apply the bias. Why bias? So because the energy of the secondary electron is less, so in order to get accelerated, we need to apply the bias. So if we will switch off the bias, okay, then secondary electron will not be accelerated, right? So in this way, we can exclude the secondary electron and the backscattered signal is obtained alone. This is one way. The another way is the collector is giving a small negative voltage. Okay, so when the collector will give a small negative voltage also, then your secondary electron can be excluded and only BSC can be detected by your ET detector. So yeah, both secondary and the backscattered electron can be detected by your ET detector. Fine. The yield of a BSC detector will be highest. Just I have explained this in a minute ago that what is where the signal of BSC will be mostly you can get. So at far from the primary electron beam, in and around the primary electron beam, at 90° to primary electron beam, and there are no such specific condition. So since if you have, because in the last to last lecture we have covered about what is the elastic scattering, what is the inelastic scattering, and how I mean BSC and the SC are generated, what are the directions, and what are some its specification regarding this backscattered electron. So can you give me the answer for this also?
B.
It's a B.
Okay, right. So
It's
yeah,
a B.
yeah, I got it. So those who gave the answer B, which is absolutely right. So okay, so again I will show you this slide again. So here you can see this is your primary electron beam is coming. Okay, so this is not, in the answer you can see it far from the electron. It's not going to the angle like in a 60° or more than the, or like this 180° or here you can say the 70 or 80 or 90. Okay, now not like that. So it is in and around the primary electron beam, which is obvious because of the elastic scattering. So if you have known the scattering part, then you will be you can guess that okay, the backscattered electron can usually near and around the primary electron beam we can get this signals, right? Because this is very small. It is almost, it is very near to the signal which came of the incident electron beam. So it will go either in the same direction or it a very few small angle, so it will deviate from the very small angle. Also when you will be see when you will see the lecture of how to detect this the whole procedure, that okay, because here when the incident electron beam strike to your specimen, there will be your backscattered electron, secondary electron, this all will be generated. Okay, and this is your ET detector. So here you can see some of the backscattered is also going and the secondary electron is also going. So only those electrons traveling along the along the direct line of sight towards the detector will be collected, and thus the geometry efficiency will be very low. It is saying so. It is about some instrumentation, and this method of detection is now rarely used, and most microscope are fitted with purpose build backscattered electron detectors. So even though the ET detectors are detecting the backscattered, but if you will watch the lecture properly, then there is a separate detector for the backscattered electron also, which is able to detect your backscattered electron separately. Okay, so this is your schematic of ET detector showing the paths of SE and the BSC electron, right? So here it is in and around the primary electron beam. Okay, so the next is in lens detector has. So there is another detector which came into the picture, which is in lens detector. So in lens detector, has what? I mean, only the SE configuration, BSC, both AC and BSC, and there is no specific. So if you know and if you have watched the lectures, you can give the answer for this. Can you guess or give me the answer? In lens detector has what?
Both AC and BAC configuration.
Okay, fine. Hmm. Okay. So this is your in-lens detector. So here you can see this is your in-lens detector. So when the in-lens detector, when the although we have here your acid detector, but when your electron or the primary beam will come and hit your specimen, then the signals will get generated and it will detect your mostly SC1 or some of the SC2 and your BSC, because the BSC will also go at a in the direction of your primary beam, only a little bit deviate. So this can be detected both. I mean the BSC will also go and SC will also go. So the high resolution SEM contains specially designed objective lens with very large magnetic field for low spherical aberration. Okay, so this lens is having designed in such a way that with a very large magnetic field, here you can see a magnetic lens will also be there for low spherical aberration. Aberration is low such that the sample may be placed within the strong magnetic field of the lens. A scintillator detector is placed within the lens and the BSC backscattered and the SC pass upwards through the lens to this detector. Okay, so here it is saying that the BSC and the SC pass upwards through the lens to this detector. So this in-lens detector is able to get the both AC and BSC. And such a system has very good collection efficiency also because it is collecting both and allows the microscope to operate at very short working distance. So this will not allow a very to work in a very long working distance. So in the further slide, we will be also seeing that what is the effect and what is the um, role of your working distance, or how it can impact your resolution and your imaging. Okay, so in in-lens detector, the disadvantage is only that this arrangement places several restriction on the size and the movement of your sample. Okay, so because it is saying that operate at very short working distance, so there could be a possibilities of your samples cannot move, and also the restriction on the size of your samples. So this is the disadvantage, and other apart from that, this is able to get the detect both AC and BSC. Okay. So ET and in-lens detectors are what? So it is mainly asking about your instrumentation, that where it has placed. So right now you have seen that where the ET detector is and where the in-lens detector is. I will also show you one slide where you will be very clear further. So mounted in SEM chamber, ET, it is asking about the ET is mounted in the SEM chamber, and in-lens detector is placed just above the objective lens, or vice versa, or C is placed just above the objective lens and mounted in the SCM chambers both. So like you have also guessed that if you have seen this very clearly, then where it could be possibly possible. So what could be the answer for this question?
B.
B.
Is it A?
Okay, so one is saying A and another one is saying B. Okay. Somebody also
Yeah,
wanted to guess
it's A.
A. Okay.
It's A.
Okay. Anybody else?
A.
A. Okay. What about others? Okay, so let's see. So the right answer will be seeing, and most of them guessed right only. So it is, again I will show you this diagram. So here you can see this will be like your SCM chamber. The SC will be your mounted on this chamber, but this in-lens detector will be your after your objective lens. Okay, your lens system will be like this in a vertical direction. If you have seen the schematic of your uh, scanning electron microscope, then but the SC detector is not in this direction, it is somewhere here, it is mounted on the chamber. So this image you see here, this is your SCM, and here this will be your in-lens detector. Okay, this is above your after your objective lens. The somewhere here your objective lens will be placed. If you will see it properly in the schematic, how the lenses are placed inside your SCM, but your secondary electron detector will mounted on the chamber of your SCM. So this will be your secondary electron detector. This side will be your EDX for the elemental analysis, and this side, this is your BSC detector. Okay, this is because it is your primary electron beam will come and it will go in a similar direction or of your primary electron beam. So and here in-lens detector also, which will detect your SC and BSC, right? So here in-lens are this side. Okay, in after the objective lens, but this is mounted on your chamber. So now the answer is for ET means secondary electron detector, which is mounted in the SCM chamber, but in-lens detectors are placed just above the objective lens, right? So from this image it is very clear. So A will be the right answer. So yeah, so this is very good participation, guys. So please keep doing this, and I know that you guys know, but maybe you are not answering, I don't know why, but yeah, it's good practice. So the next is the collection. Okay, somebody is joining. uh, Fine. So let's try to answer this question also. The collection efficiency of an inless detector will be. So this also, I mean, all the questions are somewhere related to each other. That it's not like every answer is having a very separate question, because if you will see the one slide, probably you can able to answer maybe 4 or 5 questions. So this is similarly one of them also. So very high for both SC1 and SC2, very high for both SC1, SC2, for SC1, for only SC2, and for only SC1. So what could be the answer? I mean, because just see that where it has placed, and probably from that you will be able to answer this question. So please keep guessing, or yep.
It can be A or D. I have a doubt in that. Because
Okay, fine.
some
Anybody else who wanted to give the answer? You don't want to guess?
It's A.
A. Okay, fine.
A.
A. Anybody else? Okay. So let me come to this slide. So most of them are saying A, very high for both SC1 and SC2 signal. So if you guys remembered that the when I was, maybe I have to go uh, way before, where I have shown you the SC1 and SC2. Okay, I got it. No, this is not. This is BSc. Okay, yeah, this one. So can you guys see this slide? This is, I have explained you in the last lecture. Okay, so here the SC1 is electrons are generated and leaves the surface of the specimen directly at the spot where the primary electron beam impacts on the specimen surface. So please keep remembering this. SC1 is like, where it will directly, I mean, generate where the spot, I mean, where your primary electron beam impact. Okay, but keep remembering the inless detector is mounted in such a way that it is above your, from where your primary electron beam is coming. But SE2 is what? SE2 electrons are generated after the multiple is scattering. So there is, obviously there could be the possibilities of some SE2 which are in that angle, but it is not, always and very obvious that it will detect the SE2, because here it is due to, because it will leave the sample at a greater distance from the primary beam's impact point. So there is no chance of the SE2. Okay, and because inlens will detect the SE and the BSC, but from SE also the SE1 will be the more chances, because SC1 it is primary because of the where the primary electron beam impact on the specimen surface. So this will be the reason. So please keep remember that how we are going through these lectures, that will be more useful, because this is somewhere related. I mean, it's not like that just keep forgetting the last and the previous lectures. So it's fine that you all have guessed that. I'm very glad, but here just keep noticing that the collection efficiency of inlens detector. So it is asking about the collection efficiency. So when the term came efficiencies mean not, it is like that very high for both SC1 and SC2. So just I have shown you about the SC2 signal, so the efficiency cannot be the high for the SC2. It is only for the SC1. So somebody was saying around the D, so which is absolutely right. So it is very high for your SC1. Okay, so here you can see this is your, so answer will be the D. So just keep remembering this. This is your inlens detector. Okay, this is your AT detector. This is your inlens detector. So SE2 cannot, it is not for efficient for the SE2 because here it will live far from the primary beam impact point. So that's the reason. So I hope it is clear to you all. So the SC images from the inless detector is generated entirely through detection of SE1 and sometimes SE2 electrons. So please notice this. I am not denying that the SE2 electron it will not detect. It will detect, but the thing is sometimes but the question is asking about the collection efficiency. So sometimes, but it is not very high for the SE2. Okay, so it do not include the signals by the BSC or the SC electrons, SE3 electrons. Okay, so there is a very small numerical. So I hope that in this your assignments also you got some numerical problems, and but I do not know that what kind of question did you get. But this is very simple about the pixels, specimen pixels. So it is saying calculate the size of specimen pixel in microns for a 100 display pixel size. So two parameters is given: pixel size, display pixel size which is 100, and the magnification which is 500x. So you just tell me very quickly if you know the formula. I will be also happy with the formula also.
Option A, sir. Option A.
Option A. Okay. So and anybody else?
So pixel size upon magnification.
Pixel size upon. Okay, fine. Yeah, correct.
So it is a P maybe.
Okay. So who else?
Display pixel size upon magnification.
Right. Absolutely right. Correct. So other did you guys get this that what somebody gave the very right formula, and you can see this also in the lecture. So it is asking about the size of the specimen pixels. It is in the micron. So it is about S by M, where S is your display pixel size and M is your magnification. So when you will put the value of S is given 100, M is given 500. So just divide and you can get the answer. So you just see that what could be the answer. Okay, it 1 by 5. Right? So yeah, so quite simple. Yeah.
Excuse me, can I ask a question?
Yep.
See, I understood the equation, but if you compare the option A and option B, you have the answer of 0.2 here. So why this range is given? I have also noted the same kind of range given for some other questions also in the previous assignments, and because I have missed this in the practice sections. So could you explain why this range is given?
Actually, for this question, I don't think so. The range is very important, but range is usually when you will be going to solve your numerical questions. Mostly in the gate exams or anywhere. So somewhere you have faced the problem. For an example, okay, let me give you the example of suppose if you divide. Suppose your answer is in your calculation there is 100 divided by 3. Okay, so what will be the answer to you?
It's 0.3333 it will come.
No. Yeah. So 100 divided by 3 means 33.33.
Yeah.
Yeah. So in that question, suppose if you are considering if you will feel the answer because that is an NAT kind of a question. So you will feel the 33.33. Somebody will feel the 33.34. So so they will the main objective of the examiner or who will check is to that whether you have got the question or not. It is not about accurate the things. That's why in some point of time you will get some range. Okay, so it's not like if you got the answer or the correct method to solve the question you will be able to give the answer. So it is just that's why they in the numerical kind of a question usually they give you this range.
Okay, I understood. But see, for this particular question, say that for the answer we exactly get is 0.2. So if you look at the, for example, if it is 0.2, if you look at the option A and B, you can see that point 2 is given over there.
Okay.
0.19. So which will be considered as the answer?
So how
it
can
is the A option.
Okay, so let me give the one answer. So suppose you have said just now 100 by 3, it means 33.33. Can you write the 33.33 to 33.32? No, you will be probably writing that 33.334, not 32. So usually it cannot be, obviously you are very right, you are going in the right direction. But the thing is just if you have to choose the answer, this kind of question, if you will face, then it's not like something you have to go to the lesser side, because you can't go, because it is possible that you can increase a 0.01 or zero point 0.1, but cannot reduce from that specific thing. But anyway, you are what you are saying is right, but this is my I mean to say, what should I say, I mean my observance, but you can think on this also.
Okay, so what is answer here? But what is answer here?
What will answer will be the B, 0.200 to 0.201.
Okay.
So what if I opt the option as A? There also we have an option as 0.2 there. So
where
answer is coming over there. So if you round the values also as 0.199, also it will come as 0.2. So
see,
so such kind of confusion has arisen for some other questions also. That's why I have raised this question.
That is right. Your concern is very right. But it is just, see, the 0.2 is in the both options. But thing is, in the point A, it is starting from the 0.199, which cannot be possible. Right? Obviously, there is 0.2 also in the both options, but it is starting from the 0.199. Okay, so you cannot go in a left direction, you have to go in the right direction also only. So that's the thing. Whenever you will solve this kind of question, just consider this thing. This will be, I have seen in a lot of numerical, if you will solve a numerical kind of a questions, then they will not give you a very accurate answer. Even in gate also, they will give you the range. A range is not like something like 0.2 to 0.4. They will give you, because of your this sign conversion or this point conversion, because somebody write maybe somebody can write 33.334, somebody can write 33.34, somebody can write 33.4 also, so like that only. So it's not a big deal, but the main thing of this question is you have to get it. I mean, how will you solve this? So it is very simple. This is the formula, you keep remember this. So I hope it is clear to you. Okay, is any other doubt? Anybody else wanted to ask something, or can we go ahead? Okay. So it is asking about the depth of field. Okay, so few slide backs I was discussing about a working distance. So it is somewhere related working distance. So if in a okay, so in a SCM the depth of field will be higher if working distance is smaller, larger, final aperture is greater, none of this.
B, working distance will be.
Okay, working distance is larger. Anybody else having some option they want to give the answer? Answer. What? Somebody said something? I could not hear. Please say it again. Okay, so I think let's see. So one has answered option A. So this is also related. You can get the um, relation from your depth of field. So like in the optical, when we were covering about your optical microscope, then we have gone through what is the depth of field, what is the depth of focus, and how it is related to the your some relation with your resolution, how can you get it. So it is like that. So here the formula is, so this is your the convergence angle. Okay, so this will be alpha. Alpha is, so here the h is depth of field, which is given by your s is what display pixel size, m is magnification. Okay, and a is your convergence angle. So s upon m alpha. So the depth of field, so here alpha is given by this, this is your aperture, right? Aperture upon 2 into WD, which is working distance. So depth of field, so when you will put the alpha in here, so here A will go, okay, so if alpha equals to A upon 2 working distance, so H will be come around 2S into working distance divided by A into M. Okay, so this is in mm. So here, so from here you can get the relation. So it is also asking about the first one is aperture. Okay, so here in the question it is asking, let's see, the depth of field will be higher, so this should be higher only when your aperture will be lower, but here the aperture is greater, so it cannot be possible. If your aperture will be the greater, your depth of field will be lower, but it is asking about the higher. Magnification is also, but there is no options for the magnification. So in order to get the higher depth of field, the magnification should also low. And about the working distance, so the working distance is directly related to the depth of field. So if your working distance, usually we put our working distance during the imaging, so that we can get a good or the higher depth of field. So here the working distance is larger. Okay, so answer B, working distance should be larger in order to get a higher depth of field. So
you can say in this way also, boss. If working distance is higher, then the probe size, the area which we covered for the observation will be higher. So as a result, not only this depth of field will increase, resolution will decrease because of the increase in the probe size, because of that working distance increase in working distance.
Okay. Okay. So what you want to conclude by this?
Means it also correlate with the probe size. Means the depth of field increases because of the increase in the probe size. That relates to directly with the working distance.
Okay. Okay. So you are saying that the resolution will increase.
Will decrease, boss, if it is increases. Depth of field means you are focusing more area rather than focusing on a single area.
Okay. 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 Fine. But here in this question, so we will be mainly, I mean, that's also can be possible that we have to see the, because there is everything is we need to check that whether how your probe size is, and where probe size should be the minimum, and what should be your working distance. So in this question also you can see also here, this is one image, this is another image. Okay, so particles of rapidly, this is of a solidified aluminum alloy. So left is optical microscope, okay, with numerical aperture 0.65, and this is your SCM image. So since in SCM the working distance is higher, this is giving you a good image. Okay, so here in SCM for aperture here, so since the aperture is very small, the aperture, so in this formula if you will see the aperture is inversely proportional to the h. So here it is in the micrometer. Okay, and the working distance should be the higher in order to get a good image, and magnification is giving 1000x. So the depth of field will become your 40 micrometers. So if you will see this lecture very carefully, then here you won't be able to get the information as clear as here. Here this is, even this is the particle, but at the back side also you will be clearly see the images or the distribution of your particles. So in optical microscope, it a magnification 1000x with an objective lens of numerical aperture 0.7 would have a depth of field of only 1 micrometer, but here the depth of field will be your 40 micrometer, right? So this is your SCM image. That's why in SCM you can be able to get a better image than the optical. So the B working distance should be higher in order to get the, or the larger in order to get the good depth of field. So why SCM is generally preferred for analyzing a fractured surface of a specimen? So this is again somewhere related to what I have explained. So I think this you would be able to answer. So please answer this. So why most of you, if you are a metallurgist or a mechanical, from a mechanical, if you're often doing this tensile testing, right? So you will get this fracture surface, and in order to get the morphology of your fracture specimen or the fracture surface, you will go for the SCM. Then this is very good question, that here it is generally preferred for analyzing what, why SCM is preferred for this analyzing this kind of sample. Why don't we go for optical? Why don't we go for another microscope? And just I have given you the answer. So it's very simple. Please answer this. I will also show you the diagram. This is your fracture surface. You can see. I just told you that what is the important consequence of the large depth of field of the SCM. Okay, so this is also because what? Okay, right. See, so, I think somebody has given the answer after seeing the slide. Is it like that? Okay, fine, it's fine, but it's good that somebody said at least. So over the past 30 years of SCM has contributed greatly on understanding of the fracture process. Okay, so whenever you are dealing with the fracture surface, you have to go for the SCM. Okay, so that can determine, or that can give you a good examine of your fracture surface with a very high resolution. So here you can see, you can see how your in a very good manner, that this is some lining, and how this is surface is looking. So this is also because of your large depth of field. So apart from a good spatial resolution, one of the most important aspect of a scanning electron microscope is its large depth of field. So because of its large depth of field, you will be able to, so this is in the, this is image, this is I think in a high magnification. So here also you can see the working distance is also very important. So working distance should be high, and your depth of field, that's why usually sometimes we keep around 20 mm and like that, so you can get a good depth of field. So that's the reason we go for the large depth of field to examine the fracture surface. So what is the purpose of optimizing probe size in SCM? So somebody was saying something about regarding the probe size. Okay, so maybe you can give this answer too also. So what is the purpose of optimizing the probe size? So
C.
C. Okay. Anybody else? Okay. So probe size. So when you see this slide or the lecture, so minimum. So what is the answer? Somebody said for generating sufficient and acceptable signal. Sufficient. Okay. So the probe size here can be decreased by increasing. It is showing some permutation combination. Okay, what can be increased and decreased, like increasing the strength of the condenser lens and decreasing the working distance. So it is like that, but here I have, okay, so this is the attainable probe size. So this can be given by this formula, that what could be the your probe size. Okay, so this is about, some is related to your diffraction and another is related to your I think aberration, or the I think it is aberration only, and this can be given by this your formula. So here for a typical SEM operating at 20 kilo electron volt with an objective lens of your this is given um, coefficient is 20 mm, d minimum is 2.3, and alpha is 5 into 10 is to power minus 3 radians. So this is you can also get this kind of question, so you keep remember this formula. But for this question, as the attainable probe size is decreased, so the beam current decrease. Okay, so it is asking regarding your generating sufficient and acceptable signals. So signals, it means what? In order you have to get the beam current. Okay, so probe size should be small. When it is small, then you will be able to get a signals also. So the main motivation or the purpose behind using this your suitable probe size is to generate a sufficient signal. Sufficient signals is meant to say the beam current. Okay, then only it will your detector can able to detect the signals coming from your sample. So here you can also see this lecture. This is different for the field emission gun, and in SEM we have used like a thermoionic emission filament. So this is for the different for the both. Usually we go for the field emission field emission FEG gun, but here it is given the formula for the thermoionic gun. So the probe size we need to optimize, and in such a way that the signals can be sufficient generated and it should be the acceptable. Okay, so here it is not like the generating insufficient signal, not to increase the should not increase the noise in the signal. There is no requirement to optimize the probe size. No, there is requirement to optimize the probe size. That's why this all has given that how can we optimize also. So please see this lecture also. You can get a very clear idea regarding this also, how we can get this probe size by varying this working distance, which is given by this V2. This is D is your probe size. Okay, so how it is related to your V2 U2. So here this is U1 V1 U2 V2. So please see, maybe you can get some another question where it is correlating with some another parameter. So EDS. EDS is what? Energy dispersive spectroscopy has ET detector, inless detector. So I think so. Most probably you will see this question in a next module. But in the last you can see ET detector is for what? For SC. Inless detector can detect your BSC and SC. Okay, and for the EDS, the silicon detector is. So here if you will go maybe in this module it has not covered, so you have to see the next module. So the EDS detector normally consists of a small piece of semiconducting silicon or germanium. So here the silicon detector for the EDS. Out of all, which is correct regarding the chemical analysis in electron microscope? So maybe a one or two question is only left. So let me just complete that, then we. So here the correct chemical analysis and the what is the question? Okay, so SEM used for both EDS and WDS. Okay, so WDS was energy dispersive spectroscopy, W is wavelength, whereas TM has only EDS. So what could be thought on this? So usually in SEM now we use both EDS and WDS. Okay, but in TM there is no WDS. We only use the EDS only. Okay, so here you can see the measurement of wavelength WDS and energy EDS. So here you can see that there are three kind of electron microscope commonly used in the microanalysis. So here transmission electron microscopy fitted with X-ray detectors, okay, which is EDS. But in SEM you can see both EDS and the WDS. So this we have already covered. The yield of BSC will be in and around primary electron beam, and the EDS and WDS captures what? Energy. Okay, this is just I have shown. E means energy, wavelength of the photons respectively. So EDS will be for the energy chain, WDS for the wavelength of the photons respectively. So this is clear by this slide only. So answer will be the A. So I think I hope this much amount of question can be sufficient to solve your this week assignments. Hopefully you will be able to solve these assignments.
Hello.
Hello.
Sir, I have one question.
Yeah, please ask.
It's regarding actually, if you consider high energy backscattered electrons, we know that they reflect in and around the primary where the primary beam hits. Okay, okay, on the specimen. If in case if they are away from the specimen or they are out of specimen, then how they can be reflected?
They can be detected.
Yeah, reflected or reflected, and then after reflecting, we can detect it.
Okay.
So,
So the thing is, so basically, it is not there. There would be a lot of signals will be generated. Okay, it's not like that. There is a SE detector. There will be a BSC detector. There will be a inlens detector. There will be ADX detector, and there will be a lot of signals will be generated. So it's not like the signals which cannot be detected by your BSC detector, for an example. But here it is important that whatever the detector has been fitted there, that the efficiency of the detector should be high in order to detect your BSC signals only. Obviously there would be some escape of your whatever signals you wanted to detect. It's not always possible to detect 100% of the particular signals by that respectively detector. But sometimes it is also possible that even your one detector will be able to get some other signals also, right? There is a two-way also possible. It's not always possible that your detector can detect the 100% of the signals that what you want to capture. That can also capture the some suppose your BSC detector is there, that can also capture the acid some of your secondary electron signals also. So it is not always necessary that the signals which are escaping or which is not detected by the detector. Here the importance is your efficiency. If you are using a backscatter detector, then it would be probably high efficient to detect the signals which are coming from your backscattered electron. So is meant by that. Is it clear to you?
okay.
Okay, so somebody or also having or any questions?
Yes, sir.
Yeah.
Yes, sir. My question is regarding optics in SEM. Means
Okay.
in that angle, like ray coming from condenser lens and entering to the objective lens, the angles will say it as 2 alpha naught, 2 alpha 1, or 2 alpha, like that. Why it is 2 alpha? Like why it is uh, calculated 2 alpha or 2 alpha naught, something like that? Why
Okay,
it is
let
not
me see.
alpha?
Is was it my in my slide? I which one you are saying about? I did not get.
Optics.
Was it in my slide? Any of slide?
Yes.
Okay. Let me. Okay. I think okay. This no, not
Not this one.
okay.
Not this one. Yeah.
Okay. So yeah, 2 alpha it means there will be like your see, this is your objective lens aperture, so it will be like a naming alpha naught, alpha 1, and this will be your alpha. So alpha it means suppose this will be your primary electron beam will come like this. So the angle, the one side will be alpha, the another side will be alpha. So here it is representing by your name 2 alpha. Okay, because it is combining the both. Suppose here you can see it very clearly. Can you see my cursor? Hello.
Yes, sir.
So
Yes, sir.
okay. So here if the primary electron beam will come, I don't know how the pointer I cannot. Okay, fine. Here this is primary electron beam is coming. Okay, primary electron beam is coming. So this will be your alpha and this will be your alpha. So together this will become your 2 alpha. Okay. So that this you have to take. So
Oh,
this will be your 2 alpha 1, 2 alpha naught, and 2 alpha.
okay, sir.
Anybody else is having anything or some questions?
Sir, I have a doubt regarding exam pattern. Is the only objective questions will be there, or essay type question will be there, or essay type questions only for the numericals?
Hmm. Mostly probably what I got, I'm also not clear, but the intimation that I have got is you have to be ready for both. I mean, the subjective also as well as the obviously numerical could be there, because even though it is objective or the subjective, numerical will be there. But if it is regarding the pattern, so most probably you have to be prepared for both. And you can do also one thing. Do you have the email ID of your NPTEL, that from where you got this your email every week?
See, I have already asked this question 10 days before, but I did not got the answer for these
So you
questions.
do
I
one.
asked whether the weightage of the subjective and objective questions. I
Okay.
asked that questions.
Okay, so you do one thing. You just send them the gentle reminder and ask maybe 2-3 times, because they have to reply, you know, for a many mails. So you just ask for the remind them politely, then they will be probably answer. But if they will not answer, then it is my suggestion to be prepared for both, especially for the subjective. Don't just depend on the objective.
Because in the exam pattern, it is written that it is objective, but for numericals, it is subjective. So just I wanted to clear that whether it is the same way, or for theoretical answers also or subjective will be there.
So if it is there, then you go by that method only, or probably I will be suggesting you to prepare for the subjective for both theoretical as well as the numerical. But just keep asking them. You just send them the gentle reminder, and hopefully they will reply you soon.
Okay, okay.
Okay.
Thank you.
Sometimes,
But
sometimes
please
this mails also
clear
got.
this doubt, because for we are working, so it's very difficult to remember all these
No,
points.
I got it. I got it. Your point, even though it is difficult, but
Yeah.
yeah. Yeah, it's fine, but it will be, because if I will say you something and probably you will be facing some problem later, then it
Yeah.
won't be good.
Even in objective also we are facing problems. Some of the time we found that the answers are same.
Yeah. It's fine. It's fine. Don't be
Okay.
so much worry. Just keep asking them. Maybe they will reply you, but because there are many mails, so sometimes they forgot also to reply.
Yeah. Okay. Even I put it in a feedback also, but I
Okay.
didn't answer today.